Okay, in the previous video, I tested a possible solution about how to load the controllers if they don't load, modifying the ROS controller's YAM file and the ROS controller's launch file. But the solution in the end, even if the controllers aren't loaded, it doesn't work. So when you start moving, you start looking at the tutorials of the Panda simulation, of the simulation of Panda. Let's see movie tutorials here. Get started. The tutorials are related to Noetic, but they are using the Franca Mica Panda arm. When you're launching everything goes fine, but you have to get those files to work. You have to get the Franca ROS, the movie tutorials because you're using Moveit, and the Panda movie config. Everything is on the internet. The Panda pick and place application. If you want to check pick and place, I think it is okay. And there's a special file here that it will give us a clue and hints about how Panda is working. So if you look at GitHub for Panda simulation, and there's a guy named Erdal Pickle. He's a PhD candidate at TUM, or Technical University of Munich, and he developed this thing. It's the Panda simulation. So he explained very well here how to clone and build and run the Panda, uh, its Panda simulation. So in the end, when you try to launch all the simulation of the Panda, we're just loading. There are some warnings. Possibly there are some errors. Let's see. No, there are no errors. Everything looks okay. Just the PID errors that always we got. And it doesn't matter. Just ignore it. Let's plan something. Let's move the Panda to a valid. Okay, the planning is still loading. Waiting for Farna Gripper, waiting for Farna Gripper controller, Gripper action. Let's wait a little. Now we can start planning. Here we want to start planning, okay. And the arm and the manipulator are visualized on RV's plans, okay. When you do execute, the arm is moving, and also in gazebo. Here you see the arm is moving. Not the case that we did on the UR5 and the RobotIQ. So what's different about that configuration that in my configuration doesn't work? So let's see. So I will stop here, this thing, and we'll inspect the Panda simulation. Okay, it has a simulation. If you inspect the file, it's the same file as the demo gazebo.launch. He's making all the things in the same way. He's launching gazebo with a word. He's spawning the URDF. Also, he got the robot description before. Spawn the robot on gazebo, load the controller, write a controller, a simple text file. He load the controllers, okay. He load some controllers, the join state controller, we understand that. The Pandora controller, we understand that. The hand controller, that is the gripper, okay, that's fine. And publish the TF for in the robot state publisher is necessary. Also, he launched Moveit and the planning context that enables everything about the planning on RBs. So in the end, he launched RBs and remap the joint state to that joint state desired. This is the remap class usual remapping that we need to do when we are using Moveit. If we have um, a robot in a namespace, you have to put it here, the robot name slash the states of the join states. Usually it's join states, but you can rename it anyway. In the end, this is the same thing like remapping. It's making a relay to the join states. And the odd part is here. He is launching the control node here. I don't know why, but I will explain. I know why now, but in that moment I didn't know why. Next, he spawned the join position on the panda on the controller. Just spawn the controller, it doesn't start. And run a robot state initializers. It's a node to initialize a robot in a position. He moves the robot to a desired position. So the odd things here are those three lines. So what happened? Why it worked for him and not for me? So we expect here we have a box publisher because he is spawning boxes, I think, in a future or something like that. So the options here are the robot state initializer is to initialize the robot in some state. But what we have to care about is here. If we look here, the code, okay, he's calling on a class about the controller, and then retrieve some keys, get subscribe to the command topic because we want to control the arm, and also we are trying to send some commands to that topic. So in the end, it's just a plugin because we want to control the arm. He made a plugin about that. So he made a plugin of the Panda simulation. Well, and also here is the his part that he has a control node for the robot. This is the grouping, the planning group. If you make your robotic art some planning group name, you have to put it here. And this is a hidden folder for storing some information about the configuration. Okay, stop a little bit. Let's see why. Okay, I get yes. Okay, thanks. Here is he's using Boost for making this directory on the file system, and in the end, he's trying to detect collisions about the robotic arm, and also try to control the robotic arm. So the things on here are those nodes. So when you disable the Panda simulation, okay, so when you disable the Panda simulation, these lines, you check the control of the robotic arm, and it's not happening nothing. So thanks for again for Erdal Pekel for making this simulation for the Panda. I will use it to control my UR5 and my RobotIQ. At least the first step that is planning on RVs and looking on Gazebo. Later I will try to do some pick and place and other things. But right now we are focusing on how to work with your robotic arm. Okay, so we want to move those package or some files of the package to our simulation. So in the end, what we have to do, we have to make this thing to work in that way. So here we copy the joint position controller and the robot control node, also the same list and the plugins XML and the package XML. We'll start with the those three files because are easy to change. Here, the only thing that you need to change is the name of the package. Here, you change the name of the package. On the controller plugins, you have to rename it to the name of the controller plugin. So, for example, he's using the joint position controller. If you're using joint trajectory, you don't have to put it here. I will explain later why the type is this kind of type. And also the name of the class that you are using, you have to put it here. We are using the joint position controller again. So this is the class that we are using. And the class is inside the robot control node. Well, let's look at the robot control node. So, okay. No, this is not the class here. Here is the class. Okay. The control points. So, okay, it's this plugin that we are using. So the plugin is here. UR5 RobotIQ simulation, and also we export this joint position controller and the controller base control interface controller base class. So practically is that way that we want to change. I will come back and explain it later. So when you change the plugin control name plugin, you close it, and now you are ready to change the symmetries. Okay, again you change it to the name of the package and disable the package that are not compiled. So an example, the box and the robot state initializer, we are not using it right now. If you want to use it later, just enable it, because right now I don't copy those files. I don't need it. In the end, we are finished with the configuration of the package. Now we are looking about the configuration of the controllers and the C++ files. So for the controllers, he made a custom controller that in the end is the same name as the configuration controllers here. Let's see, okay, ROS controllers. Okay, the Moveit package that you generate in the previous video, you have to change it to the default, with the only difference that you have to make a dash here, because as I told you, Moveit to when you do a configuration for one joint, it doesn't list you. So as you see, it's the same as Moveit generates in your configuration file of the Moveit 2. Just the only thing that you need to modify here is that thing. The other things remains the same. So we're done with our own configuration of Moveit file. So let's go again to the configuration of our simulations files. So we now have here, if you see, it's the same thing as the other file that is here, controllers, and this one, it's the same thing. Okay, let's put it side by side. This file, ROS controllers, is from that Moveit configuration that we generated. As you see, the joystick controller is the same. Let's put in the same. Okay, a little bit here. It's the same, practically the same. Now we have an app controller, it's the same name. The gripper controller, the same name, and also I have a joint position controller that is the same name. So we are using, I can close these things right now. We are using the type joint state controller for the joint states, the position controller for the arm controller, also for the gripper controller, And here, as you see, we have a special type of controller here. That's why we're trying to configure this thing. I want to reuse the package. I don't want to understand all the things of the package. So we have to change this thing for the same name of our simulation package. And also look at the ARM ID. This ARM ID is the same ID as this one. Let's look. Come on, come on. Okay, slide. Yes, code 5. It's the same idea of the planning group. My planning group is named ARM. Eh, I will explain here what things you need to have. You need to have a planning group name for the ARM linked to the gripper. So you have to have the ARM group, your gripper group. You have a gripper, and the special joint position controller that we are trying to do here. Because it's related to our simulation. So he made another one to control the arm, a specific one. And then the robot poses are not really important. I suppose, and I made in that way because in that way worked for me, that you have to link the n effector in that way. You have to make an n effector with the gripper, link to the last link of your robotic arm, and name the parent group, because when you link everything, you can control all the configuration of your arm and the gripper. So I think you have to put this parameter as the one that you need to make it work. The other things can remain the same. You have to also got the controllers. It doesn't matter, as you see. Okay, exit. It doesn't matter, as you see that you got the name of the controllers by default, full trajectory, because we are not using those controllers. We are using these ones. So when you modify your low-level controllers list, next we are modifying those files. Okay, I will remain it open. So here what you have to change? You have to change the name of the namespace. Actually my standard is to make the same way as the name of the package. And next thing that you need to modify here, you can remain everything the same. The only thing is the plugin. You have to rename the plugin here, and that's done on this CPP file. On the robot control node, as I told you, you have to enable the planning group name, and also he's using a directory for some a hidden directory on the file system for storing some parameters, or at least I think he's storing some kind of position of collision or something like that. Okay, I made it on the same folder of my configuration files, my package files. So you have to change this line, I think this one from here, this one, because it's using the same name of the folder for the hidden files. When you launch the simulation, if you have any problem, you can make this folder by hand if you have any problems. If not, well, uh, at the beginning I had some problems of permission, so that's why I'm telling you that. So you have to rename or make that folder enabled. And the other thing that you need to change, I think, is everything here, and that's all. Oh, obviously he have a launch file here, and the launch file, I copy paste the code to check. He launched Gazebo. You have to change everything about related about your uh, file package. In my case, I modified all those lines. You can also use find and replace here. It's more convenient than typing everything by hand, because the launch file is really straightforward, and also is it's not so much to change. I made it manually, but on large launch files and so on, you have to do it by replacing. It's better. So I changed this thing here, this thing here. So I think that I renamed the same. I remain the same names on the Gripper controller, just for don't change anything. I think we don't need the join states. It will give us an error. I can disable it to see, because my join states are published on join states. And here we're launching the robot control node, and also our controller manager is stopping the join position controllers that is here. Where is here? Join position controllers. We are stopping our custom plugin or custom controller. So when everything's fine, you just launch everything on your controllers. I mean, on your simulation about the controllers and the UR5 and the RobotIQ. So UR5 RobotIQ 85 simulation dot launch. Okay, let's see. It's near okay, because I have to source it on the workspace of the UR workspace. Now I can't do that. Let's see if everything starts okay. There are warnings about the virtual join. It doesn't matter. Now I think everything is fine. Let's wait. This is starting Gazebo. Now this is starting Arby's, and everything goes accordingly we expected, without not much saw errors related to the simulation. So we are waiting the planning group to load up. Let's see if we have it. Right now we don't have it. Let's wait a little bit. Okay, that's warnings are normal because we're using our own controller. And now we can start to plan. Okay, here is. Let's move it here a little bit. Now we can start planning. Okay, we plan okay, and we execute. And here you have the arm movie. That was a lot of research that I made. In the end, again, thanks to Erdal Bekel for making this the simulation. It helped me a lot. I had 3 weeks searching about a solution about this thing. And we also can control the Gripper. Let's look about the control of the Gripper. Okay. find a preconfigured pose of the gripper. Let's switch to the gripper and plan for the closing position of the gripper. Here, if we get closer, we are seeing that the gripper is planning, and we are executing. And when we are executing, we will see the gripper closing. So that's all. Recapping about the things that you need to do. Okay. Now this is my okay here. Recap. Okay, this is an issue that I opened on a course I'm doing about ROS. You will not see it on my GitHub. You're only seeing the video, so that's enough. So this is a paid course. Okay, recapping, you have to you have to make your own Moveit2 configuration package and rename and leave it as default. The only thing that you need to do is to make a list of the join of the gripper, because Moveit2, it doesn't make a list. It's just put you the first join and not in the way of list. So you put it at that here. Next, remain the same the ROS controller launchpad by default. And next, this is for the panda that I'm saying that everything loads with some errors and why it works. Next, you have to make a custom control launchpad or modify the ROS controller launchpad. I don't know what you want to do. You have to, on the package XML, change to the name of the package. Also in the Symmetries, change to the name of the package. And disable the nodes that we're not using. Also the joint position control, because I have a custom controller on my robotic arm, rename it to the one that you're using. Also, this is the controller files, and you have to rename the same name of the package XML, because we're using the same name type of the plugin. Next, you have to keep an eye of the names of your controllers are the same names of the default controller list package of your Moveit2 generation. The gripper controller, the controller, the jump position controller are the same names that are here. These ones. Also keep an eye about the type of the controller that we're using. Next, you modify the joint position controller CPP file from this line 8, line 60. That's all. And also the road control node, you have to modify the line 9 to the planning group ID and the line 10 to the hidden package, hidden folder that the CPP file is using. Where this is the name on the movie config for your planning group. Remembering that you have a lot of selections. When in the planning group, the one related to the arm is the name. Also, you have to remember that this name is the same name as this name here, the arm ID. We also have to modify the line 87, and that's all. Here are I'm explaining again the arm ID is the planning groups, where is I think it's not necessary, but I put it because my logic says that we need to have it to link it, and for the controller to work, we have to have a parent group. Next, okay, here again I explain why we name the arm ID arm, and here is the launch file. In the end, as I told you, I'm launching the simulation robot control node, and also spawn the joint position controller on stop mode. but it's the same file that the demo launch. The only thing is that he's calling this node stopping the jump position controller. So you can use this one or the demo launch with the modification of the robot control node. So in the end, this is the same window that I exposed to you. This is the planning of the arm. This is the movement of the arm. So this is the planning in RVs. This is the movement or execution in Gazebo, and then the same things on planning the RVs in the gripper in RVs, and also executing the gripper movement in Gazebo. So that's all. I hope you understand. And if you got the same problem to you, this is a guide how to solve it. And once again, thanks about the guy that made the panda simulation. It gave me a lot of clues about how to make it work. That's all. Thank you.